So this is Tyrannosaurus Rex, for short is T-Rex. And you can tell it's a predator because the teeth are very pointy. And you notice how the feet are very large? They don't always just bite down. They use the feet and then push and stay on top of the prey and then bite down on it. They used to think that T-Rexes hunt singly, but now some paleontologists are suggesting that they may have hunted in packs. And yeah, that's actually what's on my shirt right here. It's the butt of a T-Rex. We know that there's many other dinosaurs out there because we're not discovering like the whole skeleton. Like, say this iguanodon, for instance. At first, we only discovered the thumb spike. That's how it protects itself. And we thought it was possibly like a tooth or something. And in the very beginning, they had to use their imagination to kind of piece these animals together. And so sometimes you need pieces of the puzzle to put the puzzle together. We're only guessing. We don't exactly know what the animal completely looks like. Like, in my opinion, the Oviraptor has big feathers on the arms, has some smaller feathers on the legs, but then it has like big feathers on the side. The reason we need to use imagination for this is because lots of times people just think, I don't think I need my imagination, I can just think. They really are using their imagination. This whole thing, the dinosaurs, is partly imagination. Everything needs imagination. Every movie is imagination. Some movies are based on true stories, but they still need imagination to make up only a couple parts. Science is mind. I'm a paleontologist.
Aaron talked about how paleontologists take small amounts of bones and reconstruct entire organisms. They're really good at connecting the dots. Let's say that this jawbone is the only bone that we found on an expedition. What kind of organism is it? Well, based on these teeth, it was clearly a carnivore. The big sharp teeth. Was it on land or sea? We don't know. Based on the size of the jawbone, we could start to figure out how big this organism was. So now we've doubled the information. We have the jaw and the skull. And in the skull, we can see this huge nasal passage right here for sniffing out its prey. If we know all this information and that this was found on land in the Canadian Arctic, we can guess that this was probably a polar bear. We're connecting the dots. Curiosity-driven solutions to problems? That's cool. But sometimes it's mission critical. Creativity, that's key for figuring out dinosaurs, but it's also essential for just about any other technology. Like fighting infectious diseases. It's experimentation where the stakes are life and death. So where do you go if you have an infection? You go to the doctor's office. And there, they give you antibiotics to fight the bacteria that's infected you. All these things might work unless you have a viral infection. Viruses can be tough to battle, partially because they're really, really small. They're stout and they change with time. They evolve to fight the things that we come up with to fight them. In order to fight the fight with these little guys, we have to come up with vaccinations. Vaccinations are when you take a little bit of the virus and you put it in your body. Your body fights this virus. It figures out how to conquer this virus so that when a lot of this virus attacks you, if it does, the body knows what to do. Who in the world would think of injecting themselves with a virus? You'd think that they'd get sick. But by injecting themselves, they actually grew resistant to large doses of the virus attacking them. This has saved millions and millions of lives. Yep. Vaccinations need all sorts of creativity because new viruses are coming along and old ones are evolving. So this means that technology is required for all sciences, all technology, whether it's medicine or whether it's dinosaurs, all for the sake of the betterment of life.